Hello.
Hi.
I'll just give a few more minutes or like let everyone get on here. Hello.
Hello, hello.
Okay. Wait, let me know. He's just rebooting his computer, so he'll be on shortly.
Okay,
And we'll give another minute because I think Bella will join too.
I'm going to drop my video.
Okay, no worries.
And I'll mute also.
Then I guess Ethan, Kayla, and Olivia, have you guys gotten around to kind of testing anything out in Git, or what have you been up to this week?
Just been learning for our CSS.
Okay. More the CS Awesome course, did you say?
Yeah.
Oh, nice. Okay, cool. Yeah. And how about for you, Ethan?
I've been kind of focusing on CSS, of course, but I was gonna start experimenting with GitLab, so something might pop up today or tomorrow.
Nice. Okay. Hello.
Larry's joining. How nice. My MacBook rebooted on me, so as I was like, oh, I'm gonna get all connected.
Hi, Wade. I'm just going to watch things and all that and stay out of video and go back to me.
Yeah. So, how's it going, guys? Don't sound so excited. So I'm getting a little organized here. As I said, my MacBook rebooted on me just as I was connecting, and I want to bring up my email because Chrome's not on my dock. Oh, nice. Oh. So you guys got any questions? You know everything, right? No questions. Bella's frozen. Or Bella is truly frozen. She's not moving. So I started working on doing a drivetrain. So I have it working. So I kind of wanted to go through that to kind of like, it uses some of the basic concepts that you guys should have already studied a little bit, like what constructors are, ideas of objects, members, and fun stuff like that. So I am going to go to GitLab. Oh, Bella's unfrozen.
Hopefully my parents and siblings are leaving in like a couple minutes, so hopefully by then that'll settle my Wi-Fi out.
Oh, okay. Let's see. Multiple. Let's see. I want to share. So everybody sees my GitLab thing, right? So if you notice in the Seabot robotics group, and I encourage you guys to do this. I created a small little subgroup for myself to sit and play with the drivetrain, or this is going to be my little group that I can, my little sandbox. You don't have to create a group, you can create a branch. I'll eventually create a group probably for 2021 and put the main project inside there. And then I had a branch that I created off the master branch to work on the drivetrain.
Are we supposed to be seeing that currently, or right now we just see the About GitLab page? Just want to check where.
You should see like the web ID.
Okay, yeah, I think we're on the a different share page.
Your screen sharing is paused. How did it pause? What the hell? Stop. Let's try this again. Share.
Nice, yeah.
Okay. So in the project, you'll see there's subsystems, and you have the main robot, right? So I created a subsystem called drivetrain. And if you look at this, and this exists in last year's code as well, because I basically wrote this class last year. So you basically have a class, which everybody should know if you've been going through the CS Awesome stuff. You know, classes basically define objects. It's basically the blueprint for an object. So since this is a subsystem, it it extends this other class called subsystem base. This is what's called inheritance. So it's inheriting all the methods and members that subsystem base has. So I don't have to redeclare all those wonderful things or rewrite all those methods that may be already defined in subsystem base. And if I don't override them, or I don't rewrite them, it'll run the methods that are in that base class. So for a drivetrain subsystem, if you think about, and this is something I wanted to challenge you guys to start thinking about over the next week or so, is what are all the other subsystems and mechanisms we're going to need on the robot, and what components belong to those mechanisms. Like I can think of one, ball collector is one, right? Because we need to go pick up balls. But for the drivetrain, I put in a little comment here. It says members, and these are all the member items for the drivetrain, right? So you'll notice here I have defined victors for a left motor and a right motor, and also down here you'll notice these four down here, Victor SPX, the WPI Victor SPX, and then there's four of them. The reason I did that is on the dev board, we typically have the Victor and Victor SPX is our speed controllers. So on the dev board, which is what we typically work with, it has the Victor speed controllers. But on the actual robot, we're going to have Victor SPX controllers. So, and you'll see later on here, I created this class so that we can define, specify what type of speed controller we're using. And it'll in the constructor, it will actually construct the object based on the type of speed controller we want to use. So that's why there's those. The other thing that I have defined is this differential drive. Last year we didn't use this, and if you look at last year's drivetrain, you'll notice it's not there. And we wrote a drivetrain that was pretty straightforward, pretty simple. The reason we're using this basically makes life easier when you want to do things like drive straight following the gyro, or not having to necessarily do all the figuring out all the joystick values yourself. That's kind of what we were doing last year, kind of like using the joystick to do tank drive type stuff. Although we were using just one joystick, you could actually do a little bit of simple math and get the same effect. So this differential drive is a class from WPI Lab, and it's defined in this thing up here, this import. Excuse the puppy barking if you hear it. And then there's this thing called an enum that I created. You'll notice all these things are labeled as private. So if you've been going through the CS Awesome course, you'll notice, you should know that private means that the only thing that can access the private things is the class itself. I can't, a program that instantiates a class won't be able to access these members. The enum, you'll notice, is public. That means other things outside the class can access it really easily. All an enum is just enumerated values. So like Victor is value 1 and Victor SPX is 2. And this makes it easy to define. I use this to specify what type of motor controller we're going to use. Maybe motor type was not necessarily the best name for it. Maybe I could have named it motor or speed controller type. It works. So those are the members. So the first thing I have written as far as code-wise is this is the constructor, and all constructors, they need to be public, because otherwise if they're not public, nobody can call them. And it will yell and scream at you. You'll notice there is no return type, and the constructor has its name is just the class name. And parameters, I have specified this parameter that is a motor type, which is of type motor type, which is this enum. So this is where you specify what type of speed controller. The one reason I decided to use actually, before I get to that, this next line here, so who knows what this is? And when I say what this is, the highlighted word this, this represents in quotes. Anybody? Bueller? Belle is saying something, but she's on mute. You guys can unmute yourself. I don't care. So this represents the instance of the class, right? So it's it's not required. I could do just motor type. I do it myself just for clarity, to know that it's a member variable. There used to be other naming conventions in older languages where you would do like M underscore, the M underscore meaning member variable, just so people could read it. The other reason is also my parameter name happens to be the same name as my member variable here. If I did this, Java gets confused because it doesn't know if I'm talking about this parameter or am I talking about this member variable. This is why, like in other languages, other naming conventions, they do M underscore, so you have a different name. To be clear to Java, I put the this, so it knows, oh, I know what this is, and it assumes this is the parameter. So all this is doing is taking the parameter that I passed into the constructor and storing it in this member variable. Make sense? Yes, no? Yeah, I know. Member variables is just going to store information, right? So this is the member variable is a way for me to later on reference outside of the constructor what type of motor we're using, and you'll see that a little later on. Because once the constructor is finished, and if I don't store it someplace like in this member variable, I won't know what it is. So does that make sense? Okay. So I have it. I store the motor type in a member variable. Have you guys seen switch statements yet in the CS Awesome course? No. Okay. So a switch statement is a really convenient way to avoid having to write something like if motor type equals equal, right? Because conditional equals are equal. What is it? Victor, right? Then I would do something, right? Else if motor type equal Victor SPX, then I do blah, right? So this logic is the same as this down here, essentially. I could rewrite all this switch stuff to be like this. It's a little nicer to do it this way, because you could actually put in other cases, and maybe for Victor I want to do these three things, and then for Victor SPX, maybe if I take out the thing with the case, in the case part, you'll notice this break. That basically causes it, once it hits the break, it pops out of here. So if I remove this, whenever I did Victor, it would do all this stuff, and then it falls through and it does this, and it breaks out down below. So I could say, well, for Victors, I want to do these two things, and then also the vector as pixel. But the, whoops, command thing. But typically you're just going to put in a break. I think you should be coming up on case statements or switch statements in Java pretty soon. You can Google them too and learn all about them. So here you notice for the case when it's a Victor type, we're just creating a new Victor. The constructor for a Victor just takes the PWM port that it's plugged into. So this is where the IO map comes in. Bell looks confused. Yes?
But I'm not confused. I understand it.
Okay. So this is where the IO map is going to come in very handy. Because without it, we have no idea where things are plugged in, and we gotta look on the robot, which if you're trying to do things remotely is sort of problematic. The Victor constructor takes one parameter, which is PWM port it's plugged into. So I have these constants defined. This is where constants are handy because I just say left PWM drive. And if you go look in the robot constants, this class down here, you'll notice here, let's see here, drivetrain. I put in a nice little comment here. It says drivetrain, right drive PWM 0 and left drive PWM 1. The reason for using constants is if this needs to change, I only have to go change. And if I use the constants through the code, I only have to change it in one spot. I don't have to go find all the instances in the code where it's defined. And you notice the constants is just another class. The constants class does not have any constructor. It's just like a container. You notice everything is public. Also, you'll notice this word static. I don't think they've covered what static is, correct? So static is just tells it allows you to access these things without having to instantiate the object. So you don't have to do I don't have to do new robot constants, which is also the reason why I don't have constructor, right? Because the only way the constructor gets called is if I do new on an object, right? These are constants. I don't need to create a thing to represent, they're just constants. They're always there, and that's what static basically means. These things always exist. And so all I gotta do is do robot constants dot and then the name, right? Like I did here. So I did robot constants left drive PWM, right motor, it's robot constants, right? And so when I create the differential drive object is what's actually going to drive the motors. That's what actually sets the motor values, the PWMs on the controllers, or sets the values on the CAN ID objects down here. So I just create a new differential drive, and this guy takes a left motor. If you look at in the VS Code when you type it, let's see if I can share. I'm going to share. Oh, I don't have VS Code here. I was going to pull up the WPI-lib documentation. So.
Also, I'm wondering, I'm thinking that you must have pushed that, but in the My subgroup, I'm not seeing that code. So I wonder if it's potentially private or like if there are other permissions, because I'm guessing you'd intended that to be public, or?
I made the group public. And I tried making the project public, but apparently I did not.
Okay.
So let's see, WPI lib API doc. So you guys see this document, this WPI lib documentation? Or do you see the code still?
We see WPI documentation. We're on
Okay.
good page. Yeah.
So if I look up differential drive, it's right here. And this is just documentation for the differential drive. And it has, let's see, these are that's some example code. Down here, you'll notice, here's the constructor summary. So these are the constructors that it supports. So it has basically, the constructor takes two parameters, each of which are speed controllers, one for the left motor and one for the right motor. So you're like, but you're passing a Victor, something that's typed Victor into this controller. Well, if you look at the definition of Victor, the Victor object, you can look this up. You will notice that it inherits from PWM speed controller. And if you were to go look up this guy actually it shows up at the top here. Victor inherits up here. You have Victor, and then it inherits from PWM speed controller. And then I believe PWM speed controller also inherits from speed controller. So it implements the speed controller interface. So it works. This is where inheritance and interfaces come in. Interfaces we'll deal with later. Think of it as sort of like inheritance. But since Victor implements this speed controller interface, we're good. The class we were using last year isn't in WPI lib, and it did not support this speed controller interface, and we weren't able to use it. But the new one that we're using this year, just WPI lib, WPI Victor SPX, which is not in here either, does work, does support the speed controller. So thus, I can do this, and then if we're doing Victor SPXs, we create all four. There's four on the robot. There's actually 4 speed controllers, one for each motor, because there's 4 motors for the drivetrain. In previous years, when we used Victors, and Larry can correct me if I'm wrong on this, but we used one speed controller, but we did a Y cable, or we had a Y cable that went from one PWM port to the 2 speed controllers. So it looked like one. So we didn't have to deal with 4. For the Victor SPX, which is what we're using this year, and we're using CAN-ID, there's no such thing as a Y cable. So we actually have to define, these are commented out because I was playing around last night. And normally you can see this is a bad example of why this is, since I was just playing around, I did this last night just quickly. So in essence, in reality, this should be robot constants dot, I think it's left. Yes, it should be like that, right? If I see stuff like this in your code, I will kind of like poke you and tell you, why are you doing that? We don't like to see hard-coded values. That's what's called a hard-coded value. Oh, and I typed it wrong too. I have to look to see what constant was for the lead motor. Left lead. Oh, and right lead. Cancel. Come on. Interesting. I don't know why it's not picking it up. Because this should be the, I'm not going to check any of this in, but, and then I commented this stuff out down here. So the other nice thing, so in the case of when it's a Victor SPX, we're just creating 4 new Victor SPXs. We're specifying the CAN IDs, which are specified as constants, which you see over here. So here's all the CAN IDs for those, for how the controllers are set up. The way the controllers are, the Victor SPX CAN ID is set on the actual hardware is you take the speed controller, I think for those, actually, there's a piece of software you connect to the Robo-Rio and it detects them on the CAN bus, and there's a piece of software that will set them. There's the other controller we were using, which you actually plug into a computer using USB, and you can set it that way, which I think was the new like Spark Max or something where you're like. So again, constants, good thing. So I created 4 new Victor SPXs when we wanted to find a Victor SPX. The other thing is we do for Victor SPX, and this is kind of a cool feature for Victor SPX, is I can set like left follow motor to follow the lead motor. So if I have 4 of them, I have 2 on each side. I only have to set 1 motor. So if I set the lead motor, the follow motor automatically gets set to the same value. So it will mimic or follow the lead motor, which is nice because when I create the differential drive, again, there's no way for me to specify 4 motors when I create a differential drive. So this way, I can just give the lead motor for each side. I don't have to worry about the other 2 controllers, and they will follow the leads. Does that make sense? So makes life easy. And the only other line that happens in this constructor is this is the line, the smart dashboard dot put data. This is what makes the drive little. If you saw on the dashboard yesterday, there's the little thing that looks like the robot, and it kind of like shows the motors and stuff. And yeah, this is all you have to do to make that happen. Is you do a smart dashboard put data. This is how you make things show up on the dashboard. Usually, it's just doing a smart dashboard put data and whatever the object is, and pretty much shows up. So you can do this with the gyro. You can do this with the accelerometers. All kinds of stuff. So that dashboard, while it looks sort of complicated, it's actually pretty easy to do. So the other thing is, so there's another constructor here, right? So this is kind of what's called the default constructor. It has no parameters. So if I were to call the constructor with no parameters, does anybody know what this line means? The highlighted line. What it's going to do? Laura knows. Laura better know.
I was gonna say, who wants to take a guess?
Yes. No guess is a bad guess.
I can take a guess.
Don't be afraid. I'm not going to yell at you like, oh my God, you're an idiot. No, we're not going to do that.
Is it redefining saying the yeah, I know, robot constant is to default it?
So there is a constant called default drivetrain controller type, which if you go over here and you look at robot constants, let's see here. Here it is defined here. It basically says the default type is of motor type Victor, which, yeah, thank you for my mouse.
Is it defining it is the this there because there's more than one?
So what it's actually kind of doing, yes, there's more than one constructor, but this, when you do this and you, it's like a function call, it's like a method call, but what it's going to do is it's going to call this constructor up here. So this is a way for me to basically say, have a default value for a parameter. It's like, so if you don't give me any parameters and you want a drivetrain class, all I have to do is say this, call the constructor that's defined in this class, and here's the parameters. So then it matches the function signature, right? Function signature is name and parameter types, right? So there's a constructor up here that takes a motor type, right? That has, because the signature for the constructor has this motor type, a parameter of motor type, right? So all it's going to do is it's going to go up here and it's going to call this, but it's going to pass this constant as the parameter. Make sense?
Yeah.
So I can just say, create me a new drivetrain. I don't care about parameters, just create me your default one. And voila, yay. And I think if you were to look, and I think it's in robot container here, which is a little different from last year's code. You'll see here where I define, so in robot container, we define a bunch of the things that are in the robot. And so one of the things in the robot is a drivetrain, right?
Yeah.
So I'm just calling drivetrain. I have this drivetrain member object, and it's just creating a new drivetrain, no parameters. So the way this flows is when it calls this new, it's going to go here, and all this does is call this guy. So if I wanted to switch the robot from using Victors to Victor SPX, I just have to change this default parameter, or I probably wouldn't change the default parameter, or I would go to robot container and I would put in motor type. I could specify motor type dot Victor SPX, right? And if I did that, when it calls this new, it's going to go, it's not going to go here. It's going to just automatically go here, and then it would go through this part because I specified a Victor SPX. Make sense?
Yeah.
Cool. So the rest of this class is pretty straightforward. Again, you see a switch statement. Set left motor, set right motor. This is leftover from last year. This is, so not having the differential drive class, this is basically how we're setting the motor values. So if you think of the drivetrain, two things you need to be able to do is set the left motor and set the right motor, right? Because that's basically what you need to do to move forward or backward or turn. So again, these basically mirror themselves. They're just methods, the double. So who knows what a double is? What is it?
Isn't a double where it's a value that has a decimal in it?
Yes, floating point.
Did I get confused with an int?
Nope, it's a floating point number. Yeah, it has a decimal point in it. So this is any value from, for the motors, it's from -1 to +1. It could be like 0.9999. Integers are integer values like 1, 0. So from -1 to 0 for integers, you only have 3 values. Here you have anything from -1 to 1. So again, switch type. So if it's a Victor, we're doing the left motor. If it's a Victor SPX, we're setting the lead motor. And it has it has an extra thingy in it to do something. If you go look up Victor SPX class, it would tell you what that is. And then I had created a smart dashboard object to go put the number out into the smart dashboard to update it. So you could actually see a little thing on the dashboard to see what the left motor was doing. Since I didn't have the differential drive object, that's how I made see what the left motor was doing. Same with the right motor. These actually shouldn't be public, but they actually should probably be private, because there's no need for anybody outside the class to call these things, because I had down here, I think originally last year I called this set motor values, where you're passing in the left and the right. And the commented out part is what was in last year's code, whereas just calling set left motor value and set right motor value. So there is no need for somebody outside the class to call these things. I made them public just out of laziness, probably. Making things public isn't bad. The only thing is that when you do that, especially if you were to get into more professional software development, making things public means anybody can call them. If somebody calls it and you weren't expecting it to, it could have sort of unexpected consequences. Like in this case, right? They're public, right? So if somebody in the robot decided to call set left motor value, what do you think happens? Guesses?
It goes to the left, and you wouldn't understand why it was going to the left.
What was that?
It'd go to the left.
Only the left motors would move, right? Because we're not doing anything with the right motors. So it would sort of, yeah, it would sort of either pivot or something. But even when we're wanting to pivot on a point, the robot needs to move both the left and the right motors. So it's good. So just telling the left motors to move is going to be sort of uncoordinated. And so the right motors are going to be stationed. The right wheels are going to just be neutral or whatever they were set to previously. And the left motors are going to do what you're telling them to. So to get it to pivot on a point, you actually need to have the left motors go forward and the right motors go backwards so that they sort of like help each other out, right? Does that make sense?
Yeah.
Think of it as like a tank, right? Because if you just tell the left ones to go forward, the right ones are stuck, and it's going to make it harder for it to turn. It's not going to turn as easy. It's going to not do what you want it to do. This is a reason why this should be private, because I wouldn't want somebody to accidentally call set left motor or set right motor. They might, oh, I can do that. I can do this cheating shortcut thingy, and when all I should allow them to do is either set tank values or set arcade values. So, and so in the basically, this is what we were doing last year, these two commented out lines. And this was called set motor values last year, if you look at last year's project. And this year, since we're now able to use this differential drive, I can just do if I want to do tank mode, I can call tank drive and I get the left and right like I did before. Like think of it as a tank where you have controls for the left side and the right side. So if I want to turn or pivot, I need to do this. So it will pivot. Or if I'm wanting to do a turn, like a moving turn, like an arc, I need to put the left forward and the right not as far forward. It's so that the left is overtaking the right. Does that make sense? I see heads down. I see heavy thinking. Make sense?
Yeah.
Okay. And then arcade value. So this is, I have a joystick, right? Whoops, there it is. And I need to, we only have the one joystick to drive it, right? So we have done years where we had two joysticks and we did it in tank mode. But I only have the one joystick. So arcade mode is to allow you to drive it with the one joystick. So forward is this, and then if I want to turn, I move it to the left, right. And if I want to do an arc, I move it forward, move it kind of diagonal, all that fun stuff. Last year, without the differential drive, doing that would be, I had to do some math, and you can go back and look at last year's code as to kind of like how you do the math part. However, since we want to be able to have this thing follow gyro, and one thing, and this is for Bella to think about, when I have this joystick, and I might have a button on here that tells it to go to follow whatever the current heading on the gyro is, right? So it will just drive straight. So that way you hold that button, and no matter how much you move it to the side, it still goes straight. It doesn't deviate from that path, because as you're driving, you may get nervous, or you may kind of like, you just want, you know you have it pointed where you want it to go. You just want it to go straight, and you don't want it to like weave or anything like that. So I'm going to actually work on that part this week. So, and then this periodic function I don't use, thus there's nothing there. It does have this comes from when you create a subsystem. And you'll notice it says this is called once per scheduler run about every 50 milliseconds. So if I had code that I wanted to run regularly, I would just stick it in there. It could be like updating something, like something on the dashboard. If there's something on the dashboard that I wanted updated, I could do that. I could sort of put this smart dashboard put number down there as well. I would have to do something else other than just putting a number. So, questions so far? So, you kind of might be curious, okay, this is how this thing works, or how this is basically what defines the drive. Let's see what else I wanted to talk about today. Drivetrain, okay. So I guess we're wanting, I was basically wanting to cover drivetrain. So this is the other way that makes it work, right? So if you look at this robot container, actually, if you look at robot.java, if you look through robot.java, you'll notice it creates this robot container, which contains all the various different robot things. And then these are basically little things to initialize the robot. This robot init, this is when the robot boots up. It goes out and creates a new robot container. Robot periodic comment here, basically this is responsible for pulling buttons, newly scheduled commands. The way we're actually engaging the drivetrain is through a command. There's a command called arcade drive. This is going out, setting up this thing called a command scheduler, which will go out and schedule command. There's a disabled init, which is called once when this gets called when the robot enters the disabled mode. The comments they put in here are all pretty good about telling you when things get called and when things should be there. So this teleop init, this is what gets called when it enters teleop mode, which is the I'm driving it around mode. So I have an arcade drive object, and I go get, there's a function in the container to go get the arcade command, which is, if you look at that, it's really simple. It just returns this member variable up here that has the arcade drive member variable. It goes out and it creates this arcade command, right? So this member variable is really straightforward. And then all it does is calls, since arcade drive is a command, it schedules the command. So what we're going to talk about next is this arcade drive command. So it's pretty short, pretty simple. And you'll notice here, the arcade drive inherits from this class called command base, which is all the wonderful command stuff. It has two private member variables. It has the drivetrain, right? Because that's what it's going to use. I need a drivetrain. And the other thing it uses is the joystick. And then the constructor just has two parameters, drivetrain and the joystick. If you look at the robot container here, I have defined the drivetrain, which I called here, and the joystick, which is defined up here. And again, constant, basically just telling it where the joystick is plugged in. And this actually is the port on the driver station. There's a panel which I can show later that shows you where the what joysticks are plugged in. Yeah, so I just create a new arcade that has drivetrain and joystick. And then I add, no, I need a new mouse. So this add requirements, this basically tells the RoboRio that my command requires the drivetrain subsystem, because pretty much you need it. And what this does for you is, as we create other commands to use the drivetrain, hopefully in the next week or so, hopefully by Saturday, I'll have an example that shows why we need to do this. So basically, once we schedule this command basically runs indefinitely. That's how I'm able to control the robot all the time while it's running. Because we may write commands that once a certain condition happens, it's done, it's ended. Like maybe I want to drive a certain distance. Once I hit that distance, I'm done. The command stops and it'll do the next command. So add requirements basically tells the command system that, hey, I require this, when I'm running, I require this drivetrain. If something else comes along that requires the drivetrain that gets scheduled, this command gets canceled because it goes, well, I have another command that requires the drivetrain. I'm canceling you so that it can run, right? Because I can't have two things using the drivetrain at once. It keeps things from conflicting. Make sense? Bella looks confused.
No, I'm good. This is like
Okay.
just my resting face of
Okay.
tired of planning everything out and taking everything in.
Yeah. And I'm recording this, so if you need, you can go back and watch it again. I'll probably put it up on YouTube. That seems, because apparently Zoom only gives like a gigabyte worth of cloud storage. So if we do more than like an hour, it almost eats up the whole. It eats up a good chunk of that. So I'm just putting it up on YouTube, which is easier.
Zoom is cool, but sometimes
Huh?
it just Zoom is really cool, but sometimes it just doesn't work.
Yes. So the initialize here, this is just an initialize for the command. So it gets called once. If there's some stuff we need to initialize. For this, I don't need to initialize anything. And then the scheduler gets called like every 50 milliseconds. And so this execute function gets called every 50 milliseconds. And so all I'm doing is I'm calling set arcade values with the joystick values. You might think, and I thought this last night when I was playing, or the other day when I was playing with this, you would intuitively think that you wouldn't need the negative sign on the y-axis for the joystick. However, when I initially tried this out, things weren't going the direction I expected. Using the dashboard, using like the smart dashboard put number thing with the joystick values, I could see that actually when I push the joystick forward, that's actually a negative value. So, but the motor wants a positive value to go forward. So thus put in a negative value for, just reverse the sign on the y-axis of the joystick. But here, I'm just calling the drivetrain. I'm setting arcade values, X and Y, actually Y and X, which basically all this is doing is calling, oops, not drivetrain. I'm working on drivetrain. So yeah, it's just calling this thing down here, and it's doing differential drive with the X and the Y and X values. Make sense? So this end function, this is what happens. This gets called when the command ends. So if it's interrupted, so there's this parameter here called interrupted. So if something interrupts our command, this would be set to true. But in the case of arcade, I don't care if it's interrupted or not. If it ends, I'm going to do the same thing regardless if it's interrupted or not, right? So I just set the motors to 0, which basically means neutral. We're not going anywhere. If the robot was moving forward, it's probably going to coast a little bit. If it wasn't going anywhere, it's still not going to go anywhere. If I wanted to do something like if it was where the command got interrupted, I could do something like if interrupted, right? So those that have been doing their Java stuff, so if interrupted means what? Or it's equivalent to what? This is sort of a cheaty way of writing something longer. This is shorthand. Equal to this, right? So if interrupted, I could do some stuff. Maybe I want to do like system.out.println interrupted. Right. I could do that. That way I could see when my command gets interrupted, or maybe I want to do something different. In this case, I don't care. So I don't need to do stuff like this. So I just set the motors to 0. And this is finished command, this is finished function. All these are part of what's called the interface, or they're methods that are defined in the base class that you need to override, that you need to write your own versions of. So is finished. Basically, this gets called every 50 milliseconds or so to basically check and see if the command is done. So in this case, does this command ever finish? No. Do I want it to finish? No. So I just do, and that's why I put the simple comment. I put this comment in saying this should never end, and I just always return false. Because the scheduler will call and say, hey, are you done? I'm going to go, nope. Are you done? Nope. Are you done? Nope. I'm going to keep going until somebody interrupts me. So if we're doing like driving a distance, which we're going to have to do, then yes, once I reach that distance, then I will want to end the command, and I would want to say, if I could do, I would do something like if distance, and I'm just putting, this is not necessarily totally correct, but if distance greater than distance goal, right? Then I would do return true. Else, sorry, I hate Java because they always want the curly braces on. So other languages, you put the first one on the next line. But else I return false, right? Because also this is going to check the distance. I would have to make a call to check the encoders on the drivetrain, which we probably have some sort of like function on the drivetrain that says like drivetrain dot distance. If that is greater than our goal distance, then, and actually I probably want to do greater than or equal, right? Then I return true, else I return false. Once the command is done, then the end thing gets called, and I can set the motors to 0 and stop. Make sense? Okay. So that's been about an hour, a little over an hour today. So I think that's pretty much all I wanted to cover. Questions? So goal for this week is start thinking about subsystems we need. The one that comes to my mind, ball collector. What are the components on the ball collector? What are the motors that we have? What does it need to do?
For the ball collector, are we including encoders as well?
Do we have
Yes.
encoders on the ball collector?
Yeah, we do have encoders on the ball collector
Right.
for what position it's in.
Okay, yeah, then we'll need those. So yes, we'll have to put something in there, because otherwise, how else do you know what position it's in? Right? No, it's a great question, and it's a good question. And so it's learning how to, okay, yeah, I have this encoder. What's it using for? And asking yourself these questions. Okay, why do I need to use this? Or what does the ball collector do? What are we expecting it to do? Oh, we're expecting it to be in these 2 different positions or 3 different positions. Okay, well, how do I know what position it's in? In the past, we've had limit switches. So you could run a motor until a switch tripped. That's pretty easy. Or this year we're using encoders, right? We're going to run the motor until it gets to a certain encoder value. Okay, make sense?
Yeah.
So.
And I talked a little bit with Belle about it, but I just wanted to check in if everyone's like aware of the different challenges that we're doing and what like each of the challenges that we're doing consist of, because that'll kind of help, you know, we'll need to know that to be able to think more about what we want the robot to then do.
Mm-hmm.
So I guess Olivia, Kayla, and Ethan, are you familiar with the challenges that like, our robot will be going through?
Yeah.
Okay. Do you want to share out a little bit of like maybe 1 or 2 of them? Do you want to talk through them, and then I can share the other ones. Which ones do you remember, Ethan? Do you know all of them?
I'm trying to remember, but I can't totally remember them.
That's okay. So I had the page up yesterday. I think I did close it, but I could find it again. But essentially, 2 of them will be like kind of similar obstacle courses that we'll just need the robot to navigate. So it won't be, it'll basically just be driving around and avoiding like kind of going around certain obstacles in a specified path. And so there's 3 different courses that we'll need it to navigate autonomously. And then when Bella's driving, she'll be doing those 3 same courses plus an additional course of her driving it. And so that'll be more like, you know, the functionality of the robot being able to drive around, understanding how far it went and when to turn, to be sure that we'll like turn around each of these obstacles. And then the other one, I wanted to actually clarify on that one too, but I believe the other one is we'll have some balls loaded in it and try to score goals potentially, or driving around and picking up a few more balls to just store in the robot. So I wasn't entirely sure on that one either, but for that, if there was a shooting, then that would be going out. But I think Bella might have said we won't be doing the shooting. We'll just be doing the collecting part to store. So then that the ball collector would need to be able to go or like be down in its lower position, and then would have like a mechanism to then pull like a motor, I suppose, to then pull the conveyor belts up to be able to like pull the balls into the holding area. And I'll just take a moment and find that page to share out again if you guys wanted to take another look at that.
So, and one challenge I'd like to see you guys try and do this week, just to like work on the GitLab stuff. I'd like to see you guys take the project that's in let's see here, Seabot Robotics. Go to the Infinite Recharge at Home. Create your own branch. Check out your own branch and push a change to your branch. It can be just you put in some comment, or I don't care if it builds or whatnot. Change something whether it's adding a comment or changing a comment, and push it to your branch. So by the time we get next Saturday, I should see 4 other branches here. Call your branch, whatever you call it your first name. I don't call it Ethan's branch or Bella's branch or Olivia's branch, or Olivia branch or Ethan branch. I'll leave the name up to you. But it's to kind of like work on doing GitLab stuff and pushing a change. You guys up? It shouldn't be too hard, but you got to do it to learn how to do it. You got to practice it for it to sink in. You guys up for that? If you have problems, you can poke us and we'll help you out. Do you have anything else, Laura?
Not especially. I just shared the at-home manuals again, like in the chat. I think we might have gone over it right in the beginning, but shared that out. And then I'm thinking that the ball collector one would be the Galactic Search Challenge, where we have the robot go around a certain path, and then there's like power cells or those balls at certain areas on the court. And so we basically drive up to that certain area, collect, and then we move on to the next area and collect to try to pick up those.
Yeah.
Just wanted to check that was the
Yes.
challenge we're
Yeah.
doing, and then to, for that, and then the navigational challenges,
Mhm.
just to know what we're doing and be able to think about those components this week as well.
So goal for Saturday, I want to see 4 new branches with changes in them. So with that, does anybody have anything else? Any questions, comments? Did you guys want to meet up on just like a check-in on Tuesdays and Thursdays like we have been doing, or?
Yep. Can we do it at 6 o'clock?
6 o'clock on Tuesdays and Thursdays? Okay. I will set it up. So cool. With that, I will let you guys go and you can have fun. If you have questions, send me email. I'm sitting here anxiously awaiting questions because I don't have anything else to do. Actually, I do have other things to do, but I have to figure out the gyro thing. I would. So I'm not going to ask you guys to do things that I don't think you can figure out, like the gyro, getting the robot to drive straight on the gyro. It's not horribly complicated, but the examples I've looked at, if I gave you guys the examples to look at it, I know your brains are just going to go, because my brain is kind of doing that right now, because the way they write the examples, it's like they do some things that you kind of have to know the language to understand what they're doing. You have to be fluent in the language to know what they're doing. So I'm not going to ask you guys to figure that out. I'm going to go figure it out on my own first, and then I will teach you guys. Because we're going to have commands to go drive straight for a certain distance and then turn and then drive straight for another distance for the navigational challenges. Or we need to drive in a circle. How do we do that? So I will go try and figure that stuff out. I'll try and figure out parts of that this week. So once I understand it, then I can be a better guide to help you guys do what we need to do. So make sense? Okay. So I will let you guys go. Have a fun weekend and send me all kinds of questions.
Thank you.
Bye.
Thanks.